Find all possible inverse Z transform on this given function where xz is z plus 0.3, z divided by z plus 0.2, z plus 0.5. Now we write here x of z by z, we divide z on both sides, so it is z plus 0.2, z plus 0.5 to z. So in partial fraction expansion form we can write x of z by z is equal to a1 by z plus a2 by z plus 0.2 plus a3 by z plus 0.5. Now we have to find the values of a1, a2 and a3. So a1 is equal to z into z plus 0.2, 0.5 and z is equal to 0. So this is 0.3 by 0.2 into 0.5. Answer is 3. Now a2 is we have to find here values of a1, a2 and a3. So it is z is equal to 0.2. So we substitute z is equal to 0.2 and the answer is 1 minus 1.67. Similarly, a3 is equal to z plus 0.5 into plus 0.3 divided by z into z plus 0.2, z plus 0.5 and it is equal to minus 0.5. So we substitute this value and we get a3 is equal to minus 1.33. So xz by z is equal to 3 by z minus 1.60. 1 by z plus 0.2 is 1.33 into 1 by z plus 0.5. We rearrange this equation as z get cancelled on both the sides. So it is 3 minus 1.67 z by 0.2 minus 1.33 z by z plus 0.5. Now the different possible ROCs we write here. Different possible ROCs are, first is greater than 0.5, so xn is equal to 3 delta n minus 1.67, 0.2 raised to n un minus 1.33, 0.5 raised to n u of n. Second case is it is x of n 3 delta raised to n plus 1.67 into minus 0.2 raised to n u of minus n minus 1 plus 1.33 0.5 raised to n u of minus n minus 1. And the third case is it is in between 0.5 and 0.2. So x of n is equal to 3 plus 1.33 and 5 raised to n u of minus n minus 1. Next problem. Determine inverse Z transform of this given function. Problem was asked for 8 marks in exam. So step 1. First convert given function or equation into positive power of z, by multiplying and dividing z by 3. So the equation is x of z is equal to z cube by, how to convert it into positive, multiply and divide by z raised to 3. So it is z into plus z raised to minus 1 into z square into 1 minus z raised to minus 1 raised to. So this equation is z cube by z plus 1 z minus 1 square. So x z by z, it is z square, then z plus 1 and z minus 1 square. Now step 2. Now what is step 2? This is the case of repeated roots. So in partial fraction form we can write x of z by z is equal to a1 by z plus 1, a2 by z minus 1 plus a3 by z minus 1 square. Here we have to find the values of a1, a2 and a3. So a1 is equal to z is equal to minus 1. So substitute these values and we get a1 is equal to 1 by 4. Next is we find a3. So it is z minus 1 square by z plus 1 z minus 1 square and z is equal to. So by substituting we get the answer as it is 1 by 2. Now next is a2 is equal to d by dz of z minus 1 square it is square at z is equal to 1. So it is d. So we substitute these values and we get a2 is equal to 3 by 4. Sorry. Now next is step 3. Now put these values of a1, a2, a3 in equation xz by z. So xz by z is equal to 1 4 by z plus 1 plus 3 4 by z minus 1 plus half by z minus 1 square. So this z goes this side. So it is x of z is equal to 1 4 by z plus 1 plus 3 4 into z by z minus 1 plus half into z by z minus 1 square. Next is step 4. Now we have standard z transform pair as alpha raised to n un. Z transform is z by z minus alpha and n a raised to n un is by z minus a square. Thus inverse z transform can be written as x of n 1 by 4 minus 1 raised to n un plus 3 by 4 raised to n un plus half n u of n. The next problem was asked in junior set exam for 8 marks. Find the convolution of the signal Z transform, x1 is given and x2 is given. So solution is, first we write the given expressions. x1 of n a raised to n un and x2 of n is u of n. Now step 1, calculation of x1 of z and x2 of z. Calculate x1, it is capital x1 of z and x2 of z. So x1 of z is equal to z by minus a and x2 of z is equal to z minus 1. Now next is step 2, y of z is equal to into, so we write here z by z minus a into z by z minus 1. This is z square by z minus a, z minus 1. So we can write this y by z is equal to, this equation y by z, this z, one z comes here, it is z by z minus a into z minus 1. So next step is a into z minus plus b by z minus 1 partial derivative, where a is equal to so the value of a is a by a minus 1 by substitution, and b is equal to z minus 1 into y of z by z. So y of z by z value is this total value, so we substitute there. Then the next step is 1 by 1 minus a. Now put values of a and b in equation 1. This is equation 1. So equation 1 is y of z by z is equal to a by a minus 1 divided by z minus a plus 1 by 1 minus a by minus 1. So it is y of z is equal to a by a minus 1 into this z goes this side, right hand side, so it is z minus a plus 1 by 1 minus a into z by z minus 1. Now take inverse z transform. Y of n is equal to a minus 1 a raised to n un plus un, that is x1 of n into x2 of n is equal to a by a minus 1 a raised to n un plus 1 by 1 minus a u of n. This problem was for 8 marks. Next problem, define convolution theorem as applied to discrete time signal. Find the inverse Z transform of this given function using convolution theorem. Now first we write what is given. Given equation is x of z is equal to z by z minus 1 square. So we can write this equation as xz is equal to z by z minus 1 into 1 by z minus 1. We just split this term. So let x1 of z is equal to z by z minus 1 and x2 of z is equal to by z minus 1, that is x of z is equal to x1 of z into x2 of z. Now taking IZT, that is take IZT, that is inverse Z transform of x1 of z and x2 of z, the equation is x1 of n is equal to un and x2 of n is equal to u of n minus 1. Now x1 of n convolution x2 of n, x1 of z, x2 of z, right. Now using equation of convolution, we write here using convolution equation yn is equal to x1 of n, x2 of n. So it is summation k goes from minus infinity to infinity, x2 of k, x1 of n minus k. So here x2 of k is equal to u of k minus 1, x1 of k is equal to u of k. So replace above values. Now these two signals we have to show it in figure. So this is k u of minus k minus 1, so these two signals are shown in this figure. The next step is this overlapping is in the range of k is equal to 1 to n. We write here overlapping is in the range k is equal to 1 to n. So y of n is equal to k goes from 1 to n 1. We have standard summation formula. Standard summation formula, that is equal to n1 to n2 a raised to n, n2 minus n1 plus 1 if a is equal to 1. So here n2 is equal to n and n is equal to 1. So equation is y of n is equal to minus 1 plus 1 equal to n. So convolution x1 of n, x2 of n is equal to n u of n. Find xn for the given x of z. So x of z is given. So this is equation 1 right here. Next multiply both sides of equation 1 by z raised to n minus 1. So x of z is equal to into z raised to n minus 1, then z into z raised to n minus 1 by, so we solve this xz into z raised to n minus 1. It is 10 z raised to n. This is equation 2. Next is, now the residue of xz, we write here, residue of x of z cos z raised to n minus 1 are obtained as follows, that poles of equation 2 are p1 is equal to 1 and p2 is equal to 2. So the residue at z is equal to 1 is r of z is equal to 1 z minus 1 into 10 . So we substitute these values and we get 10 into 1 raised to n minus 2. It is minus 10 into 1 raised to n. This is equation 3. Now residue at z is equal to 2 is r of 2 is equal to z. So by substituting the value we get 10 into 2 raised to n, 2 minus 1, it is 10 into 2 raised to n. This is equation 4. Now the sequence xn is obtained by add equation 3 and 4. So x of n is equal to minus 10 1 raised to n plus 10 into 2 raised to n for n greater than equal to 0. This is the final answer.